Well, we have our first speaker in our second stream, Oleg Kolesnikov. Hello, Oleg. Hello, just a couple of words about yourself, what you do. I work for a true engineering company, and I'm engaged in developing various complex apps on .NET using microservice architecture. We are actively using this approach. Today I'd like to tell you what methods we are using when we work and how they help us. Cool. So you will be telling us about feature flags. Feature flags in the community have somewhat ambiguous image. Some tell us that it's something from the top, which we can use to test some experimental features. Some people say that it's better not to use them because they make a system more complex. What do you think? Do they really complicate things, or should we use them or not? There are such opinions. You are completely right. In our experience, we understood that there are more advantages than disadvantages. The disadvantages are there, yet we can live with them, and it's possible to fight them, to prevent them, and to control such a system. We've been successfully implementing feature flags in our company. We do it in iterations, not in a single phase. We also learn from the experience of other people who already use feature flags, and those of them who don't have them. Those who have implemented feature flags get a lot of additional revenues, additional advantages. They develop more releases, they have better communication inside the team because they have a better understanding. So in general, we like it very much, and we are developing it. I can understand how we can use feature flags, FFs, in monolithic, but you use them in microservices. Will you tell us more about the details of FF implementation in monolithic, in microservices? Sorry, I have a dedicated section to my presentation to this for this, and I will tell you more about specifics, and I will show you more examples. And one more thing, I really want to praise your testers because they have a lot of iterations to test. So are you controlling these quantities, the number of iterations? Of course, it's one of the disadvantages because you have to test features twice. Yet we really want to have better coverage there, and our testers are doing development of automatic tests. There are a number of approaches that help us to reasonably reduce the number of testings, and I will tell you more about it as well. I feel that I am moving too forward apart, and I am ready to give you the floor. Please put up your screen, put up your slides, and start your speech. I've already introduced myself, so let's go straight to the essence. I will tell you what feature flags are. We will discuss the system of managing feature flags and when do we use it. We also will look at Microsoft.FeatureManagement library, why we choose it, and what is the features, what is the functionality. We also will tell you about flags and microservices and this architecture. Let's look at the general development iteration. We have managers, we have developers, we have business representatives, so we clarify requirements and we start development, start the design in this stage. After that, we deploy it in a testing environment to be tested, and we imitate the real production environment at this stage. And after that, we have the release stage, and here we can get the real feedback from users, from a monitoring system, and it takes quite a considerable amount of time. So we are currently looking for ways to make this process faster. One of the key product indicators is time to market. We need new features to be delivered to the market as soon as possible, but we want to have sustainable quality. Our goal is to be ready to release at any particular moment. Faster deliveries help us get feedback sooner, and that helps us react and respond to both negative and positive feedbacks, and we want to make iterations quicker, make them in line with one iteration, and all these influences the design process. So we before had a dedicated branch for development. The key thing is that such branches, such trunks actually exist for a very long time. So we are currently reviewing the set, and it takes a considerable amount of time for quite faster development. We can face more conflicts. Another disadvantage is that colleagues cannot use our code from our trunk, and sometimes it's needed when tasks are interrelated. There are some other issues, and of course if we have a lot of trunks, you need to test all of them. If you have only one test environment, of course it will be difficult to test all the iterations, all the trunks. Now we started working with the trunk-based development approach. This method has only one trunk, which we call trunk. This trunk includes all releases, and we split all tasks into subtasks and provide development in short trunks, in short branches that can last up to 2 weeks. We use pull requests that are automatically developed. These developments, these changes are not that rapid. The trunk-based approach helps us delay the release if anything is not ready, and we can change releases in sequence, and feature flags are offering a helping hand here. Let's look at what feature flags are. Martin Fowler describes flags in the following way. In our code we have our switch or toggle points. This is a simple vlog. In the toggle point we work with toggle rotor entities, which is a switch, which is a toggler that defines the state of the feature. We also have 2 aspects here, which is configuration and context. The configuration includes the strategy of the flag, and it is stored in some storage. It can be stored in a dedicated settings file. The context can include any reference information that is relevant for decision making. It can be the username of the user who sent the request, the query. Depending on the scenarios, flags can be categorized. The release flags helps us make a deployment process and split it from functionality process. We have a number of projects which include a complex deployment process. After the deployment, we want to have all services up and running. We can have cache memories ready, and we want to provide this opportunity to users. With flags, we can include these new features, new functionality at a particular moment. These flags also enable us to conceal unready features. When we approve the feature, we remove the flag. Toggles can be used to experiment, for example, for A/B testing. For A/B testing, it's critical to look at what is the response of users, how they are behavior is changing, and for that we need to monitor this, to monitor these flags. These flags are quite dynamic. They are not long-living. When we end the test and the experiment, the flag is usually removed. One of the key advantages of flag usage is providing access to new functionality to dedicated individual users, for example, privileged users. For that we have the permission toggles. We also have operations toggles that help us manage infrastructure parts of applications, influencing the work of the operation of application in general. It can be helpful when we provide an upgrade, an update, and we don't know how it will influence the productivity. The flag is just a switch here, or is just a toggle. If anything goes wrong, if functionality is crashing, we can just switch off this feature without major damage to the app. Let's look at the life cycle of a release flag. The first part, the first stage, is adding the handle, adding the toggle, we insert it to the code. When we want to modify the old code, we use the Brian batch abstraction approach. We find the abstraction and the old code is becoming the realization, while in the second part we do the new development. So we provide this new functionality, this new flags, and this provides us with the opportunity. We develop our tasks and we add changes to new trunks, and we also add the code there. With flags, we are not afraid that our feature is not finalized. The flag provides the fact that it's always switched off. After that, we toggle, we switch on the flag. In our case, it's not about changing the code, it's about having some particular amount of time. We have a dedicated system which helps us manage flags to provide and to test the QA feature. We can automatically deploy for prod. We automatically switch off the flags, and they are switched on by representatives of customers or managers. The last stage, after we get the feedback, we need to remove the handle, remove the flag. We remove old flags once in several releases, so we create a dedicated task to clean up older flags. That is what we are doing. With flags, we have our developers, our designers, and also other people can switch on flags, product owners or managers, and of course it's not good for them to do it through the config file. They need a dedicated management system. Most conveniently here is to provide a web interface to the user. He can switch on the flag. In the code, the flag is just an identifier. In the system, it can be related, can be connected with metadata, meta information, with attributes or descriptions. It is also helpful to integrate with such systems as TFS and Jira. You know what flags are relevant to a particular task, and you know the configuration of the build. Of course, it's also good to measure metrics and enable audit systems, as well as provide access rights. Our projects are realized with microservice infrastructure. In one solution, we can have .NET or Java microservices. For us, it's quite relevant to provide support for all our languages using dedicated SDKs. There are a number of options, a number of scenarios. Of course, it's obvious we have ready-made solutions such as Launch Darkly. These systems are paid. We also have open source solutions for .NET. We have Moguls or Squilo. Also, we provide server sites. They provide server sites for clients. If you want to implement flags to your projects, please pay attention to these open source solutions. We are going down the path of creating our own system. Our company implements flags and functionalities, and it was not a single moment decision. Everything started with the fact that our colleagues from JavaStack created their own dashboard, and we wanted to develop this initiative to create a heterogeneous full-fledged system. I will tell you a bit more about the architecture of our solution. Our projects use Kubernetes. We have the dedicated resource there, and microservice can read parameters to their memories. If anything changes, app responds immediately. We switch on flags through a portal. We have the configuration of flags in the storage. Currently, we support such databases as SQL, MongoDB, or SQL Server. When we update a flag, we have an integration bus which receives the event in the cluster. We have a config updated component. It gets a message from the bus, and through the Kubernetes API, it changes the state. We actually deliver the configuration changes to microservices in such a way, in such an approach. This is our dashboard, control dashboard interface. Please use about naming. Please think about naming. We have some information about them. while in the code the flag is just a string. If your feature is related to a particular task, you can add its number as the name of the flag and include it in the name. In Microsoft, they have a dedicated flag library, which is Microsoft.FeatureManagement. We use it to create our control board SDK. The library uses the .NET Core configuration. This means that we do not depend on the location of our flags. We do it like that. It can be a JSON file, or it can be a database, or it can be distributed storages. We also get an automatic reboot of configuration if we update the source, but here we need to understand that our provider should support that. I'd like to point out that the library can be integrated with Azure if you use Azure in your projects. It has a dedicated dashboard for toggles, yet for us, before that, it was not relevant. Now, let's look at how we use the library. It's quite simple. You just register it, you just define the app management settings in a dedicated app, and you also add the flag functionality there. In the needed location, we add the IAF Feature Manager, and we test the functionality. This is the router. This is the router I've been mentioning to choose and not to have a lot of text identifiers. We can set up static clusters or constants, which simplifies managing dependencies. And of course, it's helpful when you will be deleting flags. It's good to have them to be able to understand references. The library, we have the FeatureGate attribute, which helps us toggle on and toggle off a controller or some particular action methods. It is a state, and it is a thing that will return the not found status. The pattern, the behavior can be customized, and the action can be changed to forbidden. There is one more feature, which is the way to provide automatic middleware container deployment management. We wanted to have a extensive logging, and we realized that we implemented this through a dedicated system, but we had a bug, and we faced a number of challenges with logging. After that, we fixed the problem using the flag, and we were quite quick to get the system back up and running. For web apps, it's very good to provide flags and have just one query. When we have a query, we address the same flag, and at some point the feature may be disabled, maybe recalculating configuration, then the flag gets a different value, but our query is still running, which is bad. Very probable that our result will be inconsistent and the behavior will be unpredictable. In such scenarios, we need to think about something else. We need to be able to run the query and finish it. For web app, we want to have the IAF Manager snapshot, and it can control all flags. When a query to the same flag will have the uniform result. Besides toggles, we have some feature filters for running strategies. We can have several feature filters. If there is one feature filter set, feature filters are disabled. There are 3 embedded filters, percentage. We also have the time window feature, and then we also have a new filter for particular groups of users to manage particular groups. To use a filter, you need to register it in the DI and define its configuration. In this case, we understand that 20% of queries will have new features, yet this filter will not be working if we need a context. If we want to have a new form, If you want to have a new form, auto form, and provide it to 20% of users. Filters work with every query of a user, and it can show both old and new pages at various timings. It will be strange. We fixed that. We created our own custom filter, which we can use to implement the interface. We have a dedicated method to have a dedicated flag which calculates a particular value. Our filter uses hash and it works with the name of the feature. It can work with values from 1 to 100, and users get always the same result all the time. I'd like to point out that in the new targeted filter, this new functionality is also working. We can use it, yet we had our own custom filter and we still use it, while at the moment we have an integrated solution. It's also relevant to change storage format in our system. This format is quite different. It is related to the fact that we all started from Java design, Java development, and we picked out a dedicated format, and we decided to support this format for all our heterogeneous apps. In the library we have the extension point, which is called Feature Definition Provider. Our framework designers suggest using this abstraction to change the sources of flag configuration. Its default implementation is about I configuration. This only works in the format that I've been describing to you earlier. We didn't want to choose the source of configuration, and we only changed the format. You can see it in the slide. It's a bit more complicated, but it looks quite similar. I mentioned that our solutions are microservice-based. There are a number of specific features, and I'd like to tell you more about them. I'd like to remind you that we use Kubernetes, and we read configurations from config maps. Our config maps are connected to a pod using the JSON configuration volume, and the .NET app can read this configuration without any issues, right, just like a dedicated file. We have one issue there, which is related to automatic reloads, and which is specific to Kubernetes only. It is related to the fact that our config map is connected to pods, not just a file, but in the form of a link. The embedded configuration provider responds to upgrades in such a case. If there is a link, it does not happen. The solution there is quite simple. It's available in this trunk. And of course, it's available in this trunk with a device. You just need to write your own provider file. It will be tracking changes in content. It can probably read its hash, and everything will be working automatically. In microservice architecture, there is one more issue, one more challenge. For example, we might have two fundamental ways of interaction when we use microservices. This is a synchronous way using HTTP protocol, or an async way using an integration bus. We use RabbitMQ bus, and there is a question on how we provide consistency in operation running if an operation is handled by several services. We need to be able to protect ourselves from unexpected flag switch, flag toggling. For example, we might have the flag toggled on in one microservice and toggled off in a different microservice. So we want to work with various flag contexts, and we deliver them, these contexts, through HTTP or AMQ between services. I'd like to tell you about several ways how we can implement it. We can send the full snapshot of configuration, we can calculate the values of all flags, and we work with the current query even when we only touched upon one flag. This is a single snapshot that we provide for headers to a different service, which is of course a redundant activity. We have a different way when we update the configuration of each flag, and we can actually use a version-based approach. Despite the current version, the apps should store the recent 5 versions, for example. Additionally, our services in such a way can communicate with each other using a way of exchanging feeders. The app actually will see what kind of flags they have, what kind of versions they have, and what kind of configuration versions are needed to handle to process the current query. There are a number of issues there as well. We implemented a different approach. We deliver services to only in the framework of queries. So this is what we call trace, and we chose the trace approach. In the library we have the abstraction, the ISession Manager. The ISession Manager abstraction is used by users, by managers. Managers create a query to find a flag, and then they get a value. In other words, we have calculations that find configuration, and they deliver, they return the session. I'd like to point out that our library designers implemented this manager to provide consistency of queries. In the previous example, we looked at hash calculations to provide consistency. We did that to provide consistency of queries from one user having the same calculation. Instead of that, we could have implemented a manager, a session manager, for example, based on .NET. In the session manager, we could have handled this issue and could have addressed this issue, yet we used the manager session to address this task that I'm talking about at the moment. We created this implementation. We have a flag context, which is just a glossary, a string ball. In the pipeline of queries, we have a middleware which initializes the context using a dedicated HTTP title of the input query. Our custom manager, in the custom manager session, we have this flag context. As a result, when we check a flag in some particular place of the code, the result of the check is delivered to the code. In the HTTP client, as you know, we have our dedicated pipeline for queries, which is provided in the form of delegated handlers. When we deliver a microservice approach, we have a dedicated flag context implementation method which adds it to the query. All this is delivered to the service. It can check several more flags. After we get a response, we provide a merging of context. After that, the query is handled, is processed, and we deliver the response to the customer. I'd like to point out that this approach has one important issue, which is about working with services. If we have several parallel queries sent to several services, and these services can check the same flag but we haven't tested, they can test it in one state and we can return a different state. This is an issue, and in practice we haven't seen it. We are trying to avoid it, yet probably in such an option, in such a case, it's probably beneficial to use versioning snapshot approaches that we've been mentioning, so you will need to work with advantages and disadvantages of the approach. In future we will probably be supporting several ways, and we'll switch approaches depending on the strategy of the configuration, depending on our framework. With RabbitMQ, we use the MassTransit library. In the MassTransit library we have our converter that works with the library, and we implement the dedicated interface to work with this. In the web apps, flags should be delivered to UI. In our case, these apps are some part of systems that are created or using Angular or React. The key thing here is that front end can pull the point and get the values of flags. You can also think up a standard response for your API that will work with flags, and it would return this response at each toggling. This is not a sustainable approach because the design of the API is becoming complex and the volume of data is growing. We use a combined approach. We have a point which is used to get the initial configuration. In the title of each response there is a dedicated title with the name, with the number of the version. Front end is responding to the change of the version. If it is changed, it can connect to the endpoint and get the new version. We also have a different realization, a different implementation to use WebSockets and using Signal R. The client setups connection, and this connection is used to provide exchange when configuration is changed. A few words on testing. Obviously, flags make this process more complex. You need to test the app twice. When we have a lot of flags, there are a number of combinations of these states. In this, we have a combinatory splash of these areas. I'd like to advise you to do the following. Not all flags depend on each other. There are a number of tasks which can be unrelated. If we have some dependency, then for the current release we want to deploy. For the current release we want to deploy to the environment. We want to use two approaches for testing. We first of all look at two cases. When all toggles, when all flags are switched off in relation to the version we're currently working with, and we also have the second options when all flags are toggled on, and very often it's quite sufficient. These approaches so far have been helpful to us. Now let's look at some conclusions. We've looked that flags speed up design, it makes releases more secure because they enable us to toggle off some features that might not be running, and they provide better freedom for experimentation, better for testing. We use the flag management system. Please use it because it makes life easier, not only for managers or for product managers, but also for designers. Of course, it's good to have all the flag configuration in one single place. If you work with MS FeatureManagement library, it's a good idea actually. You can use it to create your own SDK for your big system. This is what we did, or you can use it for some minor projects. There are some out-of-the-box solutions, and of course libraries can be used to customize. Yet, if you already use this system, if you have made up your mind to use this framework in web apps, don't forget to use the FeatureManagement snapshot. This will provide consistency to your queries out of the box. Now, this is it from my side. I'd like to thank you for your attention. And of course, I'm ready to take your questions. Oleg, thank you for your presentation. We expect a few questions, but I have a few questions of my own. This is a fantastic question I'd like to ask you. Have you faced a case when there are dependencies between features? If there is such a dependency, I can think of a situation when we have a query coming into a service. This service checks the feature flag, and it checks the dependency. Then there is the query to service B, and it needs the feature flag B. And at this particular moment, the feature flag B is switching while it should be switched off. So these two switch flags are changing their states together, and it creates the following situation. You have the service B and the service A flag will be changed. It should be some other level to control it. Well, of course, such an issue can happen. It can take place. What can be advised here? We try to avoid feature dependencies. If there are some dependencies, we can understand it. We know our tasks, we know our code when we design it. If this happens, it's better to avoid it. If we have a client query handled by several microservices, then of course it's better to have all these chain working with one flags, with the same flags. So we will need to use the same approach. We need to transfer calculated flag values from one microservice to a different microservice. If it's not possible, if you are facing some issues, you can use a head-on solution. Our flag configuration is always general, and we don't have a situation when we have only 5 flags for one microservice and different flags for different microservice. The replicas are always the same, and the number of flags is always the same. For the first microservice, we can calculate the snapshot for the entire context. It can be a context which depends on the user. All values of flags can be then delivered to other microservices. There are more overhead costs there, but we can protect ourselves by that. And the next microservice will be working with the same configuration that has been calculated. You probably will need to use this approach. It's better, it's a bit easier. We were also looking at the versioning, and we want to implement versioning to implement our system. We want to store several configuration versions. Thank you. We have many questions. Vladimir Rogozhin in the chat. Was it painful to transfer to trunk-based approach? How many designers you have, and how much time did you need to adapt all the processes? With the processes of transferring was delivered by several teams. Several teams have already switched. Some of them are still converting. There are some pain points there. It can be not that obvious. You need first of all to understand why you need it. There is a necessity to have releases more often. For example, you might sometimes delay releases, or tasks are stacking. And of course, in such a case, this approach is feasible and you can implement it. There were some painful points. Initially, it was very hard to start implementing flags. We started with simple things by incorporating flags to long-living trunks, to long-living branches. We started reducing branches and trunks. Our designers have got accustomed to using flags, and we started reducing our feature branches, and we then switched to trunk. Our teams include from 2 to 5 people. They're not big. 2 to 5 designers work on a particular project. We also have QA specialists that participate in this process, and in general it's quite convenient. Don't you have conflicts between two teams working in the same code base? After this testing period, there are no more conflicts. We get accustomed to the fact that we have a single code, and it's actually quite good because when we had longer living branches, we faced a number of issues. When we developed a feature, some new features, we have our microservice architecture, and we have our service that is integrated with some current services with its own design lifecycle, and at a particular moment we see that a release might be delayed. We have created a lot of code, we have a dedicated request, and it would be good to use this code because there were some dedicated abstractions, some dedicated features, yet we don't have this opportunity, and now we have this big feature that is lagging, and we will need to merge it somewhere, so it's really easier to rewrite this code. For trunk-based approach, we don't have these issues. There is this process of adaptation, but it's just a process. After the adaptation, things come easier.